Hi, this is Stan Lyle with MasterMath. During the lesson, you're going to come to some You Try It slides where you're asked to do problems that relate to the lesson. Hit your pause button, try the problem, and then hit the forward key to move on to the answer. I hope you have a really good time today.
This is our second lesson on graphing quadratic equations. And you're going to need some graph paper because you're going to graph some quadratic equations. So you'll want to pause the video right now and go get some graph paper. If you don't have any graph paper, you can go to my website, www.mastermath.info. And on the Lessons tab page, you'll see a link for plain graph paper. If you click that link, a window will open with graph paper on it, and you can print several pages of that to use in this lesson. And in this lesson, we're going to focus on what the B coefficient can tell us about a graph. And we're going to use an equation that's very important. It's going to tell us what the x coordinate of the vertex of the graph is. X equals minus b over 2a. We'll use that x value to determine what the maximum value is or what the minimum value is and what the axis of symmetry is. Well, let's review what we learned in the previous lesson. In the previous lesson, we wanted to focus just on the a coefficient and the c constant value. We didn't want to look at the b. So we pretended that the b equaled 0, and then we could simplify the expression to y equals ax squared plus c. Now we want to find out what that a can tell us. And we found out if that a equaled 1, we had the parent function, y equals x squared. And the parent function is a parabola that opens upward and looks just like that. Well, we also learned what happens if the a value is greater than 1. We get something called vertical stretch. Our values are stretched upward. Our y values go all the way up to 50, whereas in the parent, they only go up to 25. They go up twice as far because we've multiplied x squared by 2. We also learned what would happen if a were a fraction. In that case, we get vertical shrink. Our y values are half of the y values in the parent function. We also found out what would happen if a were a negative number. What if y equaled minus 1x squared? Well, what we learned is that in that case, the parabola is flipped over. It's upside down. It opens downward instead of opening upward. Now let's review what the c coefficient can tell us about the graph. The parent function, y equals x squared, has a c value of 0, and it looks like the parabola that's graphed there. But what if the c value were plus 2? Well, hopefully you can see that all we've done is increase every y value by 2. So the whole graph is going to be raised upward 2 above the parent function. What if our c value were minus 2? Well, then the graph would be driven downward by 2 units. Now, one thing to remember is that that c value really tells us the y-intercept. It doesn't tell us necessarily the vertex. It does tell us the vertex if b equals 0 and the parent function splits along the y-axis. But if the y-axis isn't the axis of symmetry, then the c value won't necessarily be the vertex, but it will be the y-intercept. Well, now let's focus on what the b coefficient could tell us, and we'll use a real quadratic equation to do that. If we graphed y equals 0.25x squared plus 2x plus 1, it'd look just like this. And we can see a couple of things. We can see that this parabola opens upward, which means that we have a minimum y value. We have a y value that is the minimum value, and it can't be any lower. It's right at that apex. That apex is at -4, -3. And we can't have a y value of -5 because this graph doesn't go down that far. So we have a minimum value of y equals -3. Well, how could that b and that a help us figure out what that vertex was? Well, we could use the formula x equals -b over 2a. If we substituted 2 for b and 0.25 for a, we get x equals -2 over 2 times 0.25, or x equals -4. Well, if x equals -4, I wonder what our y value would be. Well, that's easy to figure out. We just substitute -4 into our original equation, so that y equals 0.25 times -4 squared plus 2 times -4 plus 1. That simplifies to y equals 4 minus 8 plus 1, or y equals -3. Well, that -4, that's our x value at the vertex. And that also tells us what our axis of symmetry is. X equals -4. The parabola mirrors on either side of the line x equals -4. This side is identical to this side. And x equals -4 splits it right down the middle. So that -4 value we got from x equals -b over 2a tells us what the vertex is, or at least it tells us the x coordinate of the vertex. And we can figure out the y coordinate of the vertex by substituting that -4 into the equation, and we find out that -4 minus 3 is the vertex of this equation.
Now you try this one. Hit the pause button, do the problem, and then hit the forward key to move on to the answer.
I think this is pretty easy. I do. We just need to remember this formula. X equals -b over 2a. Now we'll substitute the b and the a from our equation. The -6 and the 3. We'll substitute those into this equation and find out what the x value is at our vertex. When we substitute, we get x equals -6 over 2 times 3. And that equals 1. So the x value at our vertex is 1. If we substitute 1 into the original equation, we get y equals 0. So the coordinates of our vertex are 1 and 0. And our axis of symmetry is x equals 1. Well, in the first lesson on graphing quadratics, we learned what the a coefficient and what the c constant value would tell us, and we've just focused on what the b coefficient would tell us. And if we combine all this information, we can graph pretty much any quadratic equation. For instance, I can graph y equals x squared plus 6x plus 2. And I probably want to start out by finding out what the x value at my vertex is. So I'm going to use the equation x equals -b over 2a. I'll substitute the b and the a from the actual equation, and I'll get -6 over 2 times 1. And that simplifies to -3. So at the vertex, my x value is -3. What's my y value at the vertex? Well, all I have to do is substitute minus 3 into the equation, and I can find out that my y value is minus 7. So my vertex is at minus 3, minus 7. It's right down here. Now, is that a minimum or a maximum? Does my graph open downward or does it open upward? Well, my a value is positive 1. And when my a values are positive, my graph opens upward. Now we know the vertex. That means we also know the axis of symmetry. It runs right through the vertex. And the parabola will be identical on either side of that axis of symmetry. What else do we know? Well, we know what the c coefficient is. That's plus 2. That means that this parabola is going to cross the y-axis at positive 2. It's going to cross it right here. Well, if we know that point, we can identify a point on the other side of the axis of symmetry. This point is 1, 2, 3 units from the axis of symmetry. So if we go 1, 2, 3 units on the other side of the axis of symmetry, we can identify a second point. Well, we've got 3 points. We could probably draw a parabola in there, but we can make it a little more accurate if we added a couple of more points. How would we do that? Well, let's just, for the heck of it, say we want to know what the value of the equation is when x equals 1. We could substitute 1 into the equation, and we could find out that when x equals 1, y equals 9. X equals 1, y equals 9. We got another point right there. And that point leads us to another point. We know that there's got to be a point on the other side of the axis of symmetry. And it's going to be 4 units to the left of the axis of symmetry. 1, 2, 3, 4, right there. Well, now we've got plenty of points in order to draw this graph, and it'd look just like that. Now you try this one. Hit your pause button, get some graph paper, graph the equation, and then hit your forward key to move on to my answer. All right, we're asked to graph y equals minus 1/2 x squared plus 6x plus 3. And the place you almost always want to start is by figuring out what the x value is at the vertex. Let's use the equation x equals minus b over 2a. We'll substitute the b value and the a value from our equation. And then we'll simplify and we'll come up with x equals 6. Now let's figure out what the y value at the vertex is. Let's substitute 6 into our equation and simplify that, and we discover that y equals 21. So we know that our vertex is at x6, y21. It's right up here. Now, does this open upward or downward? Well, our a coefficient is minus 1/2. So that tells us that our parabola is going to open downward. Well, that's a good start. We also know that our axis of symmetry runs right through the vertex. So we can draw that in just like that. We also know that our c value is plus 3. So we know that the y-intercept of the parabola is plus 3. It's down here at plus 3. And we know that there's going to be another point that's a reflection of that point the same distance on the other side of the axis of symmetry, right there. Well, we could probably draw a parabola with just those 3 points, but let's be a little more precise. Let's find out what the y value is when x equals 3. I picked 3 because it's right in between the axis of symmetry and the value we've got here at the y-intercept. And we discovered that when x equals 3, y equals 16.5. So I can plot another point at x equals 3, y equals 16.5. And I can plot a fifth point because for this point I'll have a mirror point on the other side of the axis of symmetry, right there. Well, now I got 5 points and I can draw my parabola and it's going to look just like that. Well, that's our second lesson on graphing quadratic equations. I hope you learned a lot. Now it's time to test your skills. Go to www.mastermath.info and you'll find some worksheets and quizzes there to help make sure you understand this concept. Hope you had a good time, hope you learned a lot, and I hope we see you again real soon.